There are several methods that can be used to create arrays. We've already looked at one method, where we type out the individual elements of our array in between square brackets. This method works great. However, if we think about creating large arrays, this method turns into a very long and tedious process. The good news is there are a couple other methods built into MATLAB that can create arrays in a much more efficient fashion. This is something, as you get more experience as a programmer, you should always be on the lookout for. Whatever your task is, what's the fastest, most efficient way to perform that task? So let's take a closer look at a couple other methods for creating arrays. Here are a few examples about several methods to create arrays. We've already looked at one method before that uses the square brackets, where we type in each and every one of the individual elements that we want to store in this array. So in this example, I'm creating a variable with the name of x and assigning it an array that has the elements 3, 4, 5, 6, and 7. When I execute this command, I've created a horizontal row vector with these values. This method works great, but there are also other methods that can make our life easier as a programmer. So let's explore some of those. I'm going to show you another example here where I create a variable with the name of y. I'm going to type in this command that uses the colon operator. Start with 3, 7. I'm going to execute this command and then explain exactly what's taken place. So with this command, we've created an array. And the colon operator helps us create that array. The way that this command reads is we're going to create an array that starts at the number 3 and go up in each element by 1 until we reach the number 7, which is this last number here. So this can be very helpful when we're creating large arrays to cut down on the number of things we have to type out. So as another example, how about z? We'll start at the number 11 and go all the way up to 24. So it saves us on things that we actually have to type out. Besides just going up by 1 from each element to the next, we can actually specify the amount we want to change between each element. So here's another example. Create a variable with the name of a. We're going to start at the number 50. I'm going to put in the colon operator. This time, instead of putting another number in here that means the end, I'll put in the number 2. Then I'll put another colon operator and then the number 66. So whenever you put these two colon operators in one command, it allows us to put a number in between. That's the difference from one element to the next. So I can do this with 2. I could do a similar thing, start at 50, go up by 3 until we reach 66. Different ways to create arrays based on what our demands are for that command. We don't have to just use positive numbers. Let's look at another example. How about C, where we start at -4, we go up by 10 until we reach 54. Just another example of how we can create different arrays. Up to this point, I've been showing you how you can go up and increase the number from one element to the next. But we can also count backwards. So for instance, I could say D here is going to start at 10, go down by 1 until we get to 0. Start at 10, go down by 1 until 0. Similarly, we could have E starts at 22, goes down by -2 until we get to 14. I think you can see the pattern then of how we can create different arrays, whether that's just going up by 1, that's the default, or if we put in 3 different numbers, now we can say the starting point, the ending point, and how much we want to change with each element. Let's look at some other methods that use built-in functions to the MATLAB programming language. Before, we've used built-in functions like the square root function, where we can use those to perform mathematical operations or mathematical expressions. In this case, we're going to use built-in functions that can be used to create arrays in a much more efficient way. The first one I'll show you is the built-in function linspace. Linspace. Here, the way that it works is we put in a starting number, we put in an ending number, and then we put in how many elements in our array that we're interested in having. So here, do 3, 10, and 8. This means start at the number 3, go up to the number 10, and have a total of 8 elements in our array. In this case, we can actually create arrays that don't even just have integer numbers. So maybe if I go back to this previous one and change it to 12, what it's going to do is have a linear spacing between the numbers, between the elements. Now, we don't have to necessarily figure out the difference from one element to the next. All we have to know is we want to start at 3, we want to end at 10, we want to have a total of 12 elements in our array. Similarly, what we can do is go down instead of just going up. So I'll do linspace. We're going to start at the number 40 here. We're going to end at 1. We'll have, how about 9 total elements, right? It will figure out the required linear spacing to fit these demands. So linspace is a very helpful one depending on the constraints you have for your problem to figure out. Let's look at a couple other built-in functions that can create special kinds of arrays. So the first one I'll show you is the built-in function of ones. This is going to create an array where all of the elements in the array are ones. So if we wanted to be able to create an array that's rectangular, that has some number of rows and some number of columns, we can type those things out. So if we say 4, 3, and execute this command, what it's going to do is create an array that has 4 rows and 3 columns, right? We could do the opposite. We could say 3 rows and 4 columns. It would change the shape. However, all the elements are ones. There's also a built-in function for zeros if we want to just have zeros in there. So let's do 2 and 6. 2 rows, 6 columns. Or the opposite, 6 by 2. So those are ones where we're filling the entire array with the same number. There's also one more special built-in function that I'll show you, and it's EYE, I. This one is actually used to create something called an identity matrix. This is going to create a square matrix, so the same number of rows and columns. In fact, this one is going to have 5 rows and 5 columns, and we have the value of 1 on the diagonal and zeros in all the other elements. It doesn't have to just be 5, it could be 3. We have on the diagonal a bunch of 1s, and all the other elements are 0. This is a special matrix or a special array that's used a lot when you get into doing things with linear algebra and combining arrays together using like multiplication. We'll come back to this at a later time, but it is good to know just all the different methods that are used in MATLAB, including the colon operator and then the built-in functions for different methods to create arrays.